Okay, in section 5.4, we are talking about logarithms. So let's first take a look at a logarithmic graph. This blue graph here is your graph of log x. And this red graph here is your graph of, I think that is a, or we'll say 2, it's not quite 2, so we'll just say a to the x. So that is your exponential graph. So a logarithm and an exponential graph, they are going to be inverses of each other. The domain of this graph is going to be from 0 to infinity. So we're going to positive infinity. The range is going to be all real numbers because we are extending slowly out and up, and then we are extending down infinitely. We're going to go through the point 1, 0 here. And then we have a vertical asymptote here, it's all the way over here, of x equals 0. To find the domain of a logarithmic graph, it's actually pretty easy here. So all we're going to do is we're going to take, if there is anything after the logarithm, you're going to take it and you're going to set it greater than 0. And then you're going to solve. So this is going to be x is greater than 5. And then that is going to be your domain. So if we take a look here, we would have the domain of 5 to positive infinity. And we can also check on the graph. Let's just check here. Change that, clear it off. Log, what was this, x minus 5. Take a look at the graph. Okay, and you look at the graph here. This one over here is very zoomed in. But take a look at the table. Okay, anything 5 or below is going to give you an error. And then once you're greater than 5, then you're going to start actually getting values. So that is where your greater than 5 is going to come in. So if I take a look at these examples here, you can go ahead and put them in your calculators if you'd like, or we can, well, we'll do both, put them in our calculator, and we will do the domain, range, asymptote, and the x-intercepts. So if I look here at this one, I should have a domain, we'll go x minus 1 is greater than 0. So we'll have a domain of x is greater than 1. This 2 here might affect the graph a little bit, and there's a special way to put this in your graphing calculator, or you can use the Desmos technology. So let's start with the graphing calculator here. If you have the 84 plus, you can actually, when you put the logarithm in, it just automatically gives you this subscript. But if you don't have the 84, like I don't have the 84, the way I would have to put this in is like so. So I'm going to go log x minus 1, close the parentheses, and then divided by this subscript here, and I'm going to do log 2. And that'll give me my graph. Okay, so we see what the graph looks like here. It looks like we're going through this point. It looks like 2, 0. And we have a x is greater than 1 for the domain. Also a vertical asymptote at 1 here. So we look at the table. We can get some values. So once we get to 1, we start getting an error. We have the point 2, 0. So right here. And we had another point at 3, 1. And then we started going up. So let's see, we're going to come down, looks like that. And then we extended up and out. And then this is going to extend down like so. And then we can draw our vertical asymptote. We'll draw that a different color here. Let me see. Okay. Didn't have a dotted line that I could draw there. Oh, it gave me the wrong type of line. There we go. There we go, vertical asymptote. So vertical asymptote at x equals 1. Okay, so we have our domain, and we write that in interval notation. That's going to be 1 to infinity. Our range is going to be all real numbers, so the range is going to be negative infinity to infinity. This is our domain. Okay, we have our asymptote of x equals 1, and we did have that x-intercept, remember, right here of 2, 0. Okay, let's go ahead for B. Let's use our graphing technology. Let's go ahead and use Desmos. So I'm going to get that pulled up for us. I'm just going to make it smaller so we can see everything. A little too small. All right, so graphing calculator. And this is what we want here. Okay, so we have y equals, so log, and that log is, oh, I can't really see this here. Function, logarithm. There's our log. There we go. Okay, so this actually is not going to give us a subscript, so we're going to have to put this in just like we did for the other one. So we're going to have parentheses. Actually, we should be okay here. X plus 5. Let's highlight that. And then we're going to go divided by x. Close that parentheses. And then divided by log 2 is how we're going to put that in. Okay, so this is what our logarithm is going to look like. Okay, notice here you've got this asymptote here at 5, which means I took this 5, x plus 5, set it greater than 0, got negative 5. Okay, and then this one here is 0, where I took the x and set that greater than 0 as well. So we've got a domain here of, we're going to go negative infinity to negative 5. And then we're going to go, look at this again, 0 to 5. So we don't have anything in between those. Okay, so keep that in mind. 0 to infinity. Then your range is still all real numbers. Okay, this was, let's see, 1, 2, 3, 4, 5. So something like, well, I gotta look at it again. Okay, so something like this. And then this was like so. So we do actually have some asymptotes here. We have a horizontal asymptote of y equals 0 right here. We have a vertical asymptote here at x equals 0. And we have another vertical asymptote here at x equals negative 5. Okay, so how these are lined up, those are your asymptotes. Negative 5 and 0 for x, or sorry, vertical, and then you have y equals 0 for the horizontal. And then finally, let's look to see if there are any intercepts here. And it does not look like I'm crossing the x-axis on this at all. So I have no x-intercepts because I have that horizontal asymptote of y equals 0. Oops. Okay. All right, so let's look at actually performing functions with our logarithms. So logarithms are inverse exponential functions. So they are going to follow this formula here, where you have log with a subscripted base, a for your answer equals e, your exponent. So I like to say log b here, where b stands for the base of an exponential function, a stands for the answer, e, that's your exponent. So pretty simple to rearrange and evaluate these functions. For example, if I apply BAE or bay, log bay here to a, I've got a base of 4, an answer, so after the equal sign, of x, and I have an exponent of 3 over 2. And if I wanted to evaluate that, I can go ahead and put that in my calculator. So I can go 4 raised to the 3 over 2 power, which is going to give me 8. Okay, and if you kind of forget this, what a fractional exponent is, I also have another acronym for you, TIBO. where t stands for the top of an exponent goes inside a radical. The bottom of the fraction in the exponent here goes outside the radical. So for example, 4 to the 3 over 2, you have your radical and you have your 4. The top of the fraction goes inside the radical. The bottom of the fraction goes outside the radical. So this is the square root of 4 cubed, which 4 cubed is 64. So this is the square root of 64, which is 8. And that's how we got that 8 there. Let's take a look at B. So you have log B. You make B your base. 27 is your answer after the equal sign. And then E is 3. So we say, what cubed is 27? And if we don't know that right off the bat, we would do the opposite of cube and take the cube root. We know the cube root of 27 is 3. We can go ahead here to C. Okay, BAE, you have a base of 8, an answer of 4, an exponent of x. Okay, now this one you have to be a little creative here. You say, oh, what 8 to what power is 4? It's going to get smaller. But they do have a common base in common. So if you go back to lesson 5.3, you could say if these both have a 2 in common, 8 is 2 cubed, and 4 is 2 squared, 4 is 2 squared. Okay, then I can evaluate this because now they have the same base, and I just bring down that x. Set those equal to each other, you get 3x equals 2. And looks like x is going to be 2/3 here. And go ahead and evaluate that. 8 to the 2/3 should be 4. So we go here and we say 8 to the 2/3. And we get 4. Okay, then we'll do the same thing for D. You have B, A, E. So our base is x. Our answer is 16. And our exponent is 4. So what to the 4th power is 16? If I don't know that, I can do the opposite root and do the 4th root of 16, which should be 2. But let me show you how to do this in your calculator, just in case. If you have a larger root than square root, you can go to your calculator, or cube root, sorry, you put the number in, so I want the 4th root, and then go to math, and then come down here to where it's x root. So you're just putting the 4 in for that x to say I want the 4th root of 16. And then it'll give you your value. Okay, let's move on to common logarithm. Common logarithm is that log button in your calculator. Common logarithm has a base of 10. Okay, so a log 12 is a common logarithm here. Log with a base of, oh, can't really see that, 10. Okay, you can evaluate that in your calculator. Let me show you in a second. But you can also take that and you can rearrange it. So base would be 10, your answer would be 12, your exponent would be x. Okay, if you wanted to check it. So here we could say log 12 gives you 1.079. So we get here that x equals 1.079. And if I want to check that, I say 10 to this power. So second answer here for the power gives me 12. So it's 10 to this 10.079 is 12. So that by that measure, we can do B would be log 0.1. That's -1. And log to the 3/5 would give me -0.222. Okay, now if the logarithm button in your calculator automatically prompts you to put a base in, and there isn't one, like in these problems, then you would just put a 10 for your base. A natural logarithm is actually written as ln, but it is a log with a base e. So ln 12 is the same thing as saying log base e 12. Okay, so if I evaluate these, I can also check them. So if I have natural log, so this is the button to the left of 4, 12, I get 2.485. And if I want to check that, I can rearrange this logarithm like so. So log base e 12, and then go ahead and make that x. You have a base of e, an answer of 12, and an exponent of x. So you can say e, so second e, to this power here, so second answer, gives you 12. So that's how you would check that one. When the natural log and the e are right next to each other, because they are inverses of each other, because of this, okay, they are going to cancel each other out. So this is just 10. Okay, and then our next one, ln to the 3/5, you can go ahead and put that in here, natural log, 3 divided by 5, and that's going to give you negative 0.511. Okay, so what I want you to do now is pause the video and then go in and do these practice problems. When you're finished with them, press play, and I will go over the practice problems. So we're going to evaluate A and B here. So first one, and if it doesn't have like an equals x afterwards, you can just go ahead and add that in. That's not a problem, okay, because you're still trying to figure out what this is. So we'd say here our base, answer, exponent. So our base is 7. Our answer after the equal sign is 1. Our exponent is x. So here you're like, this looks weird, but then you remember that anything to the 0 power is 1. So here, x equals 0. So that's actually a property of a logarithm. Okay, if you have a 1 here in this a spot, then after the logarithm you're going to have 0, because anything to the power of 0 is going to give you 1. And I can take a look at B. Let's see. So I have a base of 4, an answer of x, an exponent of 5. So here I want to know what 4 to the 5th is. And that is going to be 1024. And then number 2, I want to find the domain of g of x equals ln x plus 8. You're going to find the domain of a natural log the same way you do with a normal logarithm. So here I would take this x plus 8, set it greater than 0. That's going to give me x should be greater than negative 8. So my domain should be negative 8 to infinity. Let's go ahead and check it. I'm just going to put it in my graphing calculator. So I'm going to put ln and then in parentheses x plus 8 and graph. And there we go, negative 8 to infinity. You can check your table. When you get to that negative 8, you're going to start getting an error. All right, and then number 3, we're going to evaluate this last logarithm here. So you've got log bay, your base is 9, your answer is x, your exponent is 2. So 9 squared is 81. So there your answer is 81.